Oh, the backup man is gone, maybe, Merrick. That's it, yeah. So I don't know now. Oh, jeez, no. Wait till you see the perks, Merrick. They're, if you look on your wages, they're under the SFA, which stands for sweet fuck all. Okay, so now, so each person is going to be a thread, right? Simple as that. All right. So it's going to assign you threads as we need to weigh more animals. All right. Now this is going to be done by forking and joining. Now, forking is the process of assigning tasks to a new thread. That's what forking is. Okay? Forking is assigning new tasks to a new thread. So we see that one thread is measuring or is weighing 3 animals. At that stage, we're going to do a fork and we're going to get another thread to weigh 3 animals. Now, it could also be 3 tasks. You have one person carrying out 3 tasks. He can't carry out any more than 3 tasks at one time. So you have a fork and another person takes care of another 3 tasks. Okay? So the base case is weighing 3 animals. Yes? So we start off with 10. So that's what we start off with. And we work down to 3 animals. All right? Now, this is not easy. There's the only way to describe it. Recursion is difficult enough, and this tries to use recursion with threads, which is not easy. Okay? Now, so forking is the process of assigning task or tasks to a new thread. Now, joining, the right definition here. So we have it here. Now, so what joining is, it's not what you think it is, by the way, all right? It's the equivalent of the cyclic barrier, all right? It's the equivalent of, it causes the current thread to wait until the previous thread has finished its work, all right? That's what join does. So instead of thread.sleep, you use, it's called a join. Why they call it a join, I do not know.
So you're not merging threads back together?
No. Which is really, why do they call it joining? I don't know. Forking makes sense. It's putting it, it's forking off to a second, you know. Yeah, one road and it's forking. All right. Joining is not actually putting them back together again. Okay. What joining is, it's called usually after a fork, and it causes the curtain. So it's basically whatever the fork is, right? The fork won't implement until this join here is done. Whatever the join, there's some task here that has to be accomplished before this thread will run. So it's the equivalent of a sleep, really. Right? Now, why they call it a join, I don't know. Forking makes sense because it's the one thread that's splitting into another thread, right? Too much tasks on one. So you have this thread continues with its 3 tasks. You have another thread that takes another 3 tasks, okay? But before it can fork, you can put in a join to say, do this before it forks, okay? Now, oh, no, a fork will work, but you can put in a join before a fork, right? Right, so here we are. We have one thread, right? And this one thread performs 3 tasks, all right? Or weigh 3 animals. Now, we have 9 animals, 6 animals to weigh, we'll say, okay? So what happens then is you create a fork. That's a fork on the road. So this guy continues doing these 3 tasks, but this other guy is going to do another 3 tasks. Okay, so this is T1 thread. T1 thread continues on here, but we have a second thread called T2. Now, you can set in something here called join. Okay, you can put it in, you don't have to put it in. That's the important thing, you don't have to put in a join. But if you put it in there, you'll say, these 3 tasks will not go ahead until these 3 tasks have been finished. Okay, so it's like a cyclic barrier, it's a bit like a thread. All right, that's my understanding of it anyway. All right, now, forks aren't too difficult. Joins, okay, I haven't got it right one working yet. So forks aren't too bad. Joins are a bit, is the best way to describe them. Right, so we're going to attempt to do a couple of forks and a couple. Well, we'll try a join. I'm not too 100% sure if it's going to work. All right, now, so I'm going to put in a comment here above static void ex5. All right, so in order to use, now this is fork. Join, your class either has to extend the abstract class its recursive action and implement the void compute method. Okay. Now, if you want to return a value, we extend the recursive task T abstract class and implement the T compute method. Okay, now for this one here, we're going to be using something called the manager class. C manager class. And this one here, we're going to use, we have it actually there, C employee class. So we're going to be using examples of the recursive action void compute method. That's going to be the manager class. And we're also going to use recursive task. Now, we supply the type, so it could be a double, it could be an integer, it could be a dog, it could be a cat, it could be a string. Okay, so that means that compute will return a double if this is set to double, it'll return cat if this is set to cat, it'll return string if that's set to string. Yes? Okay. Now, so what are we trying to do in this? So I'll just say what fork is. Fork is assigning a new task or tasks to a, is assigning task or task to a new thread. The existing thread forks in 2. I think it can fork in 3, it can fork in 4, it can fork in 5. Okay, so it doesn't have to, it's not just this sort of fork. It can be this sort of fork. Okay, so a fork doesn't have to be just one fork in the road. It can be several forks in the road. Yeah? Okay. Now, join. Now, I'm going to take the book. Join can be called, it doesn't have to be, after the fork method. and causes current thread to wait for a result from another task or subtask. Now, it's effectively asleep, I think. Okay, don't quote me on that. It's asleep with probably a bit of cyclic, what do I call those things again? Yeah. Okay. So it's a bit like a sleep and a cyclic barrier. Now I have the fork ones all done out, but I haven't a join one done out. So we mightn't get to the join done today. We might wait for the join until tomorrow morning. Okay. Anyway, so what is our problem? So here's our problem. Now we want to weigh all the animals in the zoo. Okay. Of which there are 10 animals, and then add up all the weights. Now I chose 10 because it's easy to calculate them out in your head as well. Any more animal, now if it works for 10, it should work for 1,000 animals. Do you understand that? Okay. So if it works properly for 10, it should also work for 1,000. So what you usually do is you work with small numbers first, and then you scale it up. Okay. 10 animals, then add up to weights. Okay. As our animals are spread out, one person can at most weigh 3 animals at one time. Okay. So we know at start of problem, one person can weigh at most 3 animals. Okay, so this is our base case. Okay, in our recursive calls, so this is our base case in our recursive calls. So this is our base case in our recursive call will get us to one person thread weighing 3 animals. Now, in reality, what actually I end up with, okay, is 7 people. Okay, it's just the way to sign them out. It found it quicker for 7 threads to weigh 7 individual animals, and then we had 1 thread was weighing 2, so that brings us to 8, and then I had another thread that was doing 3, that'll bring us to 10. Okay, that's just the way it did it out. Okay, it works out whichever one is the fastest. Now it does all this for you. You don't have to prick around with it. All right, you don't have to tell it to wait or any of that sort of shit. You can use a join in it. There's no need to. All right, so let's put a little bit further about this. Yeah. Uh-huh. 3 at a time. No, because it's just the way the computer assigns them out. It just looks at the machine and it's almost like an instant decision, which is faster, having 3 threads to do 3 tasks each, or 7 threads to do 1 task each, 1 thread to do 2, 1 thread to do 3. That's a faster combination. It just does it like that.
That's faster than 10 doing what?
Yeah. Apparently so. Huh? Well, do you know what we might do tomorrow morning? We might test it to see.
Oh, I'm sure it knows what it's doing.
Oh, don't be fucking sure of that. Do not be sure that shit in, shit out. Remember that. Actually, shit in, more shit out. Nearly always is. Okay? So, now, just further. So we want to weigh all the animals in 1 hour. Weigh all the animals in the least time possible. So we ask one person to do this, and he can, so he has permission to ask others to help him. Okay? So at the start, we don't know how many others he will ask to help him. Okay? So at the start, we don't know how many others will ask to help him. But he will ask a certain amount of people to weigh a certain amount of animals. Now, we do a small bit of trickery. I don't know if it's cheating, but what the? But to weigh a certain amount of animals. Now, here's the thing as well. We don't know at the very start how many animals each person will weigh. Okay? So we're used to knowing what exactly is going to happen. Okay? We're used to knowing that divide up the tasks, we could say we have 4 people. Those 4 people are going to do 3 tasks each, and 1 person is going to do 1 task. Okay? You have 4 people weighing 3 animals. You have 3 people weighing 3 animals. You have 1 person weighing 1 animal. Okay? Here we're letting these fork joins determine what person is going to weigh what animal. All right? Now, it's designed to be more efficient than us just doing 4 people weighing 10 elephants. Okay? It's automatic allocation, I suppose. All right? So you are going into a small bit here. These are the sort of algorithms that are going to be working in the background of machine learning. Remember the machine learning thing you showed us, Iggy?
It's like operations research.
Sorry?
It's like operations research optimization.
Yeah. Okay. So this is typical of the sort of things that's going to be going on in the background of those algorithms. All right. So now, if you want to develop your own artificial intelligence, be my guest. Now, it uses neural networks and all sorts of shit that I don't know anything about. But these are some of the techniques that they're going to learn. It learns as it's going along. It learns what is the most efficient way to weigh 10 elements. And the way it came up with here was 7 people. I don't know why it does that now, but apparently it's faster. Now, you're not going to see much, if you're weighing 10 animals, you're not going to see much improvement. If you're weighing 10,000 animals, then you'll see the improvement. All right? So we'll try it with 10 animals, and we'll try and scale it up and see if there's much of an improvement. Now, there should be. Not guarantee that there will be. You might have to scale it up to 100,000 animals to see the improvement. 10 elephants, yeah.
So it's 10 tasks.
Well, there's 10 tasks, yeah. Each one of them is a task. Okay? Now, a single thread can do many tasks. Remember that? Now, so we go down here. Now, I'm going to start off with here. We are going to create an array of weights. Okay? So weights is going to be doubles. Now, I'm not going to bother using a set because array is just handier. It's smaller. Okay. So new double. And we're going to have 10. So what's this going to be? This is going to be used to store the weights of our animals. Okay. And we want to get the total weight. So this could be applied to a farm, this could be applied to a zoo, this could be applied to a country of animals. If you want to weigh every deer in Ireland, okay, so this should work for 10 animals as easily as it should work for 1 million animals. All right, that's the whole idea of it. Now we have to create the classes that are going to use fork join. All right, so the first guy who's going to be measuring our animals is going to be the manager. Okay, I know that's not what a manager usually does, but this manager is really hands-on. Okay, so public class manager extends recursive action. Okay, recursive action, it sounds like, I don't know, a really bad pop song. Okay, so add on implemented methods. There it is. Protected void compute. Okay, now it has to be protected. I don't know why. I presume there's some reason. Okay. Now, so we're not going to put anything in this method first. All right, we're not going to put any method in there. So this is overriding the compute method. Now, compute method, this is what allows forks and joins. Okay, this is what allows forks and joins. Okay, so let's make sure here. Now, so manager. Now we're going to have a couple of things in here. Now, so we need to know when we're starting at a weight. Okay, so private int start. Okay, now this will be starting point, which will be 0. So we have 10 weights, so we start at 0 weights. Private int end. Okay, this will be the end point, which will be 10. Okay, so for dealing with our 10 weights. So we start at 0, we finish at 10. And in here as well, I'm also going to have an array, private, double, weights. This is an array of 10 weights. Now, it's not an array of 10 weights. This is the array of weights that each manager measures. So our people are going to be called managers. Now we end up with 7 managers. Now 7 of those managers is only going to have 1 weight in this array. There's 1 manager that has, sorry, I'm going to have 6 managers that's going to have 1 weight in this array. I'm going to have 1 manager that's going to have 2, that will bring us to 8. Sorry. Yeah, we print out the results anyway, okay? 1 manager has 3, 1 manager has 2, that brings us to 5. So 5 managers have 1, okay? So 5 managers weigh 1 animal, 1 manager weighs 2, 1 manager weighs 3. That's what I end up with. Sometimes, but not all the time. Okay. Now, so I'm going to have a manager constructor here. Now, also before I do that, I want to see how many managers are created. Now, again, I don't know if this works actually correctly, but I'll try it anyway. So I go public manager, and we're going to go double weights, int start, int end. So we're counter plus plus. And go this dot start is equal to start. This dot end is equal to end. This dot weights is equal to weights. Now, so the start is going to be determined. Say this. Right. So start and end. Actually, I'm just after seeing here. It does produce 4 managers. I stand corrected. Okay. It does produce 4 managers. I was reading 7 from somewhere else. So it is going 3 weights for 3 managers and 1 weight for 1 manager, which makes more sense, really, to be fucking honest. Okay, so it does produce 4 managers. Now the counter there is not working. All right, so I need to find a way of how to count the actual amount of managers that have been created. Is that okay, everyone? Right. It's neither here nor there, right? Now, so now we have the compute method. So now, previously, when we go back to here, when we're doing recursion, we saw that you have to have an if and an else when you have a recursion. All right. So the if is the base case. The else is what you do if it's not the base case. Yes. So remember here. So this is your recursion method. That's what it is. So you have to have a if statement. Now you could have a ternary operator. You could even have a case statement, but I think an if else is quite the simplest one. Okay, an if statement or something similar. Okay, the if part is the base case we are working down to. In this case, it will be one manager weighing 3 animals. Okay, now, so the else part is the recursive step, and we'll keep calling the compute method until it gets down to the base case. Now, so end and start is going to determine how many weights the person has. Okay, so the very start of our program, the start point is going to be 0. The end point is going to be 9. Yes, including 9. Not 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Right. Now, so that's the amount of weights, and we want each thread, each manager to weigh a maximum of 3 animals. Okay, it's going to be array numbering. Array numbering goes from 0 to 9. So that's the first one. That's the 10th one. Yes? Right. Now, so what we want to do is we want to make sure, so this is the start. This is the end. Okay? So how do you get the difference between the start and the end? You subtract that one from that one. Okay? Yeah. All right? Should that be right? Two from 2. Right, hold on a second here now. I think I've done this right now. Just bear with me a minute here. Right. So we want to work down. So it starts off with 0 to 9. Now we want to work down to those 3. Yes? Okay. So the end is going to be at index position 2. The start is going to be at index position 0. Okay. So we want to work down that there's only 3 positions between start and end. Yeah? So what we say is, take off here. I told you this shit was difficult. So the if statement, this is the base case. So if end minus start is less than or equal to 3. Okay, so the end is always going to be after the start. All right, so you can imagine the situation that we have our 4 threads. Okay, thread 1 is going to have 3 tasks assigned to it. Thread 2 is going to have 3 tasks assigned to it, or 3 tasks assigned to it. Thread 3 is going to have 3 tasks to it. Okay, now the next one will only give you 1. So T4, which is the 4th manager, only has 1 task. Okay, now this is all done automatically. Well, we have to do a small bit of calculations in it. Okay, now, so the else part is going to be doing the recursive stuff. Okay, this is going to be if we have at most 3 tasks for an individual thread. Okay, if we have 3 weights. Now for the first 3 threads, it's going to be 3, but for the last thread, it's going to be 1 task. Okay, now so if the end minus the start is less than or equal to 3, okay, if it's less than or equal to 3, first thing we're going to do inside it is we're going to do a for loop. Then I is equal to start, I is less than end, I plus plus. Okay, so now we're going to weigh, so at most there's going to be 3 weights, no more than that. Okay, you can't have less than that. So I am going to go weights I is equal to, I'm going to do this. I'll go math dot random multiplied by 100. Okay, now that'll get us very random weights. And then I'm going to do I'm going to say what the animal is, the animal weight is. So it is going to be okay, sorry. So animal number is plus I. And weight is weight I. Now I will go through this all. If you don't understand it now, it's no problem. I'm going to go through the whole lot of it. All right. So that's the recursive, or sorry, that's for the base case. Okay, so we're working down to that. It only weighs the animals when you only have 3 weights at the most to do. Okay, so this is the base case. Only 3 at most animals to be weighed. Oh, now here comes the difficult part. This if part. Now we need to have a recursive part. Right? So this is the recursive part. That works down to the base case. Now, so here's what I'm going to do. What's the easiest way to divide up tasks? Does anyone know? To divide up a number of anything into smaller. Exactly. That's exactly it. That is the easiest way to divide up things into tasks. All right. For instance, I don't know. Is it? I don't think this is a bubble sort. If you have 50 numbers, if you have 100 numbers between 1 and 1,000, okay. If you divide up those numbers into 50, 50, 50, all right. Huh? Binary search, that's it. Okay. And you just check, and if they're all sorted in order, all right, all you have to do is check is the midway point greater or less than the number you're looking for. See if it's there. Okay. So it's a binary search. So this is effectively a binary search we're doing here. All right. Now, so what we're doing is we want to get the middle. Okay. So I'm going to get the middle. Now, I haven't, this should work for 1,000,000 animals as easily as it should work for 10 animals, right? And we just have 10 animals. So I'm going to say int middle is equal to the start plus the end minus start divided by 2. And we want to make sure that that's in that guy there. Now, so what's happening here? So when this starts, okay, so when this starts, that starts off at 0. Okay, this is the very start, the very first one. And the end is 10 basically. Okay, so you have 10 minus 0 divided by 2. So that's 10 minus 0. That's 10 divided by 2 is going to give us 5. Is everyone with me so far? Yes? So the middle is said to be 5. Now, I want to put in a print statement because I want to see what's happening in the middle of it. So, yeah.
And maybe that's not the reason you start the same by 2, which you have 5 as well.
Yeah.
Like you wouldn't have to kind of add on the difference to the start time. But I don't know.
Yeah, I'd have to think it through, Kieran.
Yeah.
I would have to think it through. It's possible, yeah. Probably would. Okay. So I'm going to go. So this is the very first time. So we go. Let me just see. We have start is start. We go middle is middle. We have end is now. Now I just want to I'll just call this method first and we should see it working. So just bear with me a second. So I'm just going to copy this in here. Now, it's a method called invoke all. Now, this is the equivalent of the, how will I say it? This is the equivalent of the executor service. All right? This is the equivalent of the executor service. Now, to make sure I'm doing this right. Now, so what's happening here? Now, so if I run this the first time, okay, it's going to create a manager with start is going to be just a minute here now. Start is going to be 0. End is going to be, middle is going to be 5. End is going to be 10. Okay, that's what you're going to start off with. All right. So you run it the first time, it's going to go start, middle, end, it's going to go 0, 5, 10. Run it the second time. So the second manager then is going to be, oh fuck, I'm doing a bad job explaining this. Let me just go back to this class here. All right, I'm going to copy and paste in all the code and then I'm going to explain it because one thing feeds into another. So just bear with me a minute here. All right. So now I will come back to the manager class. Don't worry, right? So, but I have to do a couple other things here first. All right. So to create a fork join, there are 3 steps you need to carry out. First thing is create a fork join task. In our case, will be creating a manager to weigh some animals. Okay. Create a fork giant pool. Okay, which is going to be mount. So it's a shared where the threads for weighing animals come from. Okay. Just like the thread pools, this is a fork giant pool. Okay. This is a fork giant pool, which is going to be dynamic. And fork giant tasks, these are tasks that can be added to any thread. Okay. And finally, you will need a class that implements either recursive action, that extends, either recursive action or recursive task. Right, so we are going to create a fork join task. Okay, so fork join task. Now, you have to provide with that guy. Okay, now when we're going to be creating because this guy, the manager class implements the recursive action which returns nothing. Okay, recursive action which returns nothing. It's the equivalent of the runnable. Okay, recursive action is the equivalent of the runnable, so it returns nothing. All right, so fork join task does have a generic. All right, but you have to put in a question mark there because this is going to be using a manager, which is a recursive action, and the compute method returns nothing. Okay, returns nothing. So I go here, I'm going to call this. Sorry? No, because I'll show you how in a minute. So I'll just call this task is equal to new manager. So manager takes our array called weights, starts off at 0 and finishes at weights.length, which will be 10. Now, so I need to import this guy. Now, I can't put manager in there. Okay? Because the compute method of the manager class returns void. And the return type is not goes in there. Okay? Now, if it was a, what do I call it? Recursive task, then you could put a type in there. Now you have to put a type in there. You have to put in question mark. Even though nothing is returned. As to why, I'm not 100% sure why. Okay, but so a recursive action returns void. So what are we sending to it? We're sending it to our array of weights. That's the start point. That's the end point. First thing it does when it goes to the, now this calls the compute method. This compute method is going to keep working down until it gets to this number, so this number minus this number is going to be 3. Okay, so it's going to be this number minus this number gets down to 3, and then it's going to assign at the most 3 weights into this array. Okay, so that's what it's going to do. Now, so that's the fork. Now that's a task. That's a recursive task. That's what that is. Okay. Now that task can be shared across many threads. It can be shared across many employees. Now, so if I want to share it across many threads, what I need to do is I need to create a fork join pool. And I'm going to call it pool is equal to new fork join pool. Fork join pool. That's a whole different thing. Right. Now, luckily, I had a look at one or two of the questions. They don't ask you much about this because it's kind of something that's still so new. Most programmers would not have a clue about this. All right. So you're way ahead of probably 90% of programmers out there. They wouldn't have a clue what is happening here. Right. So you're not going to be asked an awful lot about it, but it's no harm to know it anyway. So fork join pool is equal to new fork join pool. So what is this? This is the pool of threads we're going to use. Okay, so this is the pool of threads that will accomplish the recursive, the above recursive task. Okay, now they're assigned automatically. So if it sees that 4 threads is the most efficient way to weigh out 10 animals, then it will use 4 threads. Okay, if it sees that 4 threads are the most efficient way to weigh 3 animals at the one time, then this pool will have 4 threads. So now, it's not at this point that our threads are created. The point that our threads are created is down here. So when we add our task to our pool, so a fork join pool allows a single task to be broken up across many threads. So this could be a really, really complex problem. All right, that takes a lot of work. By using this technique, you can automatically assign different parts of the problem to different threads. All right, now the size is only determined, the size of the pool is only determined at this time. Pool dot invoke. Now, so it has to take a fork join task, which is this guy up here. Task. Now, what does that do? That calls the compute method. This is the guy here that calls the compute method. This is the guy here that gives this fork join pool a size. It's the size of 4. Okay, so this fork join pool has 4 threads. It's only this guy here that gives that guy a size. So put in the comment, it's only at this point is a size given to our pool. Now, if you want to get the pool, the size of the pool, let's say size of the pool is, I go here, pool dot get pool size. And I want to print off all of the weights. We'll see each of the weights. So weights. Again, I'm going to use a stream. So I go weights dot. Hold on. I'll do this one. Arrays dot as list weights. Stream. What the fuck, yeah. That stream dot for each, and it takes in a double, and I'm going to go system.out print TLN. I'm going to say weight is plus T. Now hopefully this will print out right. Okay, so now the size of this pool is dynamic. All right, the size of this pool is dynamic. It depends totally on how many threads it will take to produce this task. All right, so if it takes 4 threads to do this task, then this fork pool join is going to be of size 4. Yes? So this guy here matches the amount of threads needed. You've seen before that when we were doing threads, when we were doing the previous example up here, let's go up here a minute. When we were doing cyclic barriers, okay, with a new fixed thread pool, we had cyclic barrier of size 4. Okay, you had a cyclic barrier of size 4. Now, down here, what this invoke does, this creates a fork join pool of size 4. All right, so instead of cyclic barriers, what you have, or whatever you call them, cyclic, is it barriers you call them? Is it cyclic barriers they're called? Yeah, instead of cyclic barriers, what you have is a join. All right, so you have the one person doing they're weighing their 3 things. It won't start until that the person has weighed 3 animals. Then the next person will weigh 3 animals. Okay, that's the way the join works, I think. Okay, I'm going to run it first and see is it producing the correct values. Okay. Right, so this is EX5. So I'm going to go to main. I'm going to go to examples EX5. Right. So start is 0, middle is 5, end is 10. Start is 0, middle is 2, end is 5. Start is 5, end is 7, end is 10. Okay. Now here it's using 5. Okay. Here it's using 5. Now we can see the first weight take was that one. That's the 5th one. That's the 7th one. That's the 2nd one. That's the 8th one. That's the 6th one. That's the 1st one. That's the so on and so forth. Okay. So all the weights are going on there, and the weights should match. So we see if we need 81. Yeah, we do. All right. Now that is a thread pool of 5. Okay. That is a thread pool of 5. Now, the unfortunate thing is that's producing different results to what I have here. So I need to figure out why is it doing that. 5. So it is determined. What are you getting there for?
Size of pool is 4.
Yeah, size of pool for me is 5. I'm going to run the exact same code here on, it's on the same machine. It's giving me 4. Right. Right, now, so I'm going to try and explain this. Can I take a break for 5 minutes? Because my brain is starting to overheat here, but so I just need to pause and I need to powder my nose. And just to make sure I'm explaining it right before I explain it to you. Okay, just going to pause that for a second as well. I need to run across and get our wipes, so bear with me.
Or punch the 3.
Right, so I just do a small bit of fucking don't know right here myself. Okay. So manager.
80 to 120,000 predicted.
Huh?
In Ireland. Worst case scenario, 80% of the population The death rate of 2 to 3%, 80 to 120,000 deaths.
Yeah, but you see, what they'll do, Jason, if they have to, they'll do it like Italy, and that will stop it. Because they'll have to. Like they're remarkably blazy back there. I mean, for fuck's sake. I said, what about evening classes? Will they have to go ahead? I was going to say, why? It still hasn't fucking fully got into their head. Sorry? Yeah, so it could like, they could stop us, but it might take. Okay. Yeah, I think I have it now. Sorry. Oh boy. Okay, so it's the same fucking thing. Yeah, sorry, nearly there now. Okay. So I'll try and get that one. All right. So, Manage counters. Okay, so so make that a public. Fuck it. Shite. Oh. Oh. Now, setting it, manage counter. Okay. So, yeah, nearly finished now. Right. Okay. Okay, so, oh, you're heading again. That's going to get. Okay, right, so I'm going to resume the share now. Now, so I've done a little bit of changing to it. Okay, and don't worry, I'll come back to it again tomorrow morning. So, oh, is it frozen? I'll unfreeze it. Now, so these print off all the weights, whatever. Okay, and now these are the amount of managers that's created. The 7 being created. All right. However, the way it's set up at the moment is that it creates managers and then it sees how many weights that manager has. Okay. So it creates 3 that have 5 weights. All right. It creates 3 that have 5 weights. But so what it does is it further subdivides each one of those 3 by 2. Okay. Now we're trying to get down. So what to remember that? So I'll go back to here. So go here to manager. All right. Now I created a static int manage counter. Okay. Now, and inside here, so the only managers that actually do the weight is these ones. So I have a manage counter inside here. So this is what each task is going to be. Each task is going to be that. Now, so we want to get down to the end and the start is less than or equal to 3. All right. Now, so what do I mean by that? All right, so at the very start, the first one it does, it gets int middle is equal to start plus end minus start divided by 2. Okay? And start is 10 or 0. Middle is 5. End is 10. Now, how does it get to there? How it got to there is, so, and then it goes to invoke all. Now, invoke all is the recursive method call. Okay? Now, if you look at that, what's it invoking? It's calling new, it's sending new manager, and it's sending weights, start, and middle. Okay? Which is, if we look back here in examples, is exactly the same as this guy here. Okay? Now, because invoke all is, it's this being called recursively. This, so when I go pool.invoke task, right? It's doing this. New manager weight 0, blah, 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 blah. Okay? Which this invoke sends this task. Where does it send it to? It sends it to the manager class. Okay? And it's not yet at 3. The end and start is not yet at 3. So it sends in the manager, which is going to have a start of 0, a weight of 5. Sorry, it's going to have a start of 0. It's going to have a middle of 5, and it's going to have an end of 10. Then we go, so that, if you go finish minus start, will give us 5. We don't want to do that. Okay? So we then create 2 new managers here. Okay? Oh, fuck it. I have to leave something out there. Hold on a second. Okay. Then we create, all right, now I know what I'm doing. Right, sorry about that. Right, so sorry, start that again. All right, so we start off with, this guy is going to be 0. This guy is going to be 5. This guy is going to be 10. Everyone with me so far, yeah? Right, now, then I go invoke all. Now invoke all is the same as the fork task method, okay? So this guy here is exactly the same as this guy here, except it's going to do recursively, right? So it's going to keep doing that. And what is it going to keep doing? It's going to do the following, all right? So it's going to create something with the weights, all right? So that's going to be our array of weights. Now, it's going to pass in the start as the start point, and it's going to turn in the middle as the end point. So that's going to pass in the weights. It's going to start pass in 0 and 5. Okay, that's going to pass in 0 and 5, which will print off start is 0. Now, it goes from 0 to 5, which is 5. 5 multiplied by 2 is integer division. So what is 5 divided by 2? What's 5 divided by 2? 2. Okay, so this one here. So start is 0, middle is 2, end is 5. Okay, so That is that one. I create another one here. Now this is for the latter half. So it goes from the middle, which is 5 to 10. Okay, goes from 5 to 10. Now none of those three are going to be doing the wing. Okay, because the first guy has got 5 weights. The second guy has got 5 weights. The third guy has got, sorry, the first guy has got 10 weights. The second guy has got 5 weights. The third guy has also got 5 weights. So the invoke all means it's going to do it recursively again. Okay? Now, so it calls both of these recursively. Okay? It calls both of these recursively. And what you end up with when you divide that guy by 2 is 2. Okay? So then you go start. So it's 2. 2 is less than or equal to 3. 2 is less than or equal to 3, so it doesn't go into the else. It goes to here. Okay? End minus starts is 2. All right? Manage counter, manager with ID. It's going to go weight, I, mat dot random multiply by 100. Animal number is I dot weight, weight is weights. Okay? Now, I'm going to go through all that again, don't you worry. So I'm going to run it. Okay. Seven, 1, 2, 1. That is. So we can see manager with ID 4, manager with ID 5, manager with ID 7, manager with ID 7. They are only the 4 managers that do all of our weighing. Okay. Now, if I wanted to find out which did what, now I will go through it again. All right. My head is even sore myself trying to fucking figure it out.
You mentioned that it's 4.
Mm-hmm.
That each of the manager would freedom would have 2.
Yeah, that's the thing. Now I have to.
One would have 3.
Yeah, so there's some things. Yeah, I have to kind of. I have to see which one is doing. So we should have 3 doing 3 and 1 doing 4. Now, how I can do that is, so manager counter. So manager with ID, blah, blah, blah. It's manager with ID 4. What I can do is I can put in static. I can put in int animal count. So each manager has its own animal count. So I can say inside here, animal count plus plus. All right. And at the end of that, bear with me here, Alice. So I can say manager with ID of ID ways, I can say, what's the weight? It is animal count. So we'll see how many animals each manager weighs. I'll do this. So manager with ID of 4 weighs 2. Manager with ID of 5 weighs 3. Manager with ID of 6 weighs 2. Manager with ID of 7 weighs 3. 3 plus 2, 3 plus 2 is 5. Now it might be different the next time around it. It is. Okay, so we have 4, 5, 7, 6, 2, 3, 3, 2.
It's all about 2, 3, 3, 2, right?
Yeah, but the only thing is,
That makes sense.
yeah, but the division 5 divided by 2 gives us 2. I'll go through the whole logic thing again, okay? So 3, 2, 3, 2. So it's always going to be some variation of 3 and 2, 3 and 2. Yeah? Okay, similarly. Right, so I'll go through it again. And there's a flaw in my logic somewhere, but it's working out, but I'm explaining something wrong.
You could teach some next album, it's going to be 5 threads and do 2 tests, so that there's more than 3 tests between 2.
No, obviously not. Okay, so now it might be different on your machines. Right, so I go back to examples. I create an array of double weights. I create a task. Now, fork join task, because manager implements or extends the abstract class recursive action, and that returns nothing. The compute method returns nothing. Okay, so then I have fork join pool. Pool is equal to new fork join pool. All right, these are going to be the threads that we're going to be used to divide up our recursive task. This is a recursive task. All right, now pool.invoke task. That is what gives this guy a size. Okay, this is what gives this guy a size. Okay, so it's going to basically create threads as needed, I suppose. Okay, so now the size of the pool is, so this guy here sends this object to the compute method. All right, and inside the compute method, this happens as well. Okay, inside the compute method, so it's recursive. Now it keeps creating a new manager until it gets to a manager that has only at most 3 weights to weigh. Okay, so it keeps creating managers until it creates a manager that at most is going to be weighing 3 animals. Yes? Okay, right. So we go to the manager class. Okay, now the manager we send to the class or to the method, so it's compute. When we go invoke all, that calls the compute method. All right, now it starts off with a start point of 0 and an end point of, so that's the start and this is the end. 10. Okay, now so we're not going to go to the end part first, we're going to go to the recursive part first. Okay, so we start off with start is going to be 0 plus 10 minus 0 is going to be 0 divided by 2, which is going to give us 5. Okay, so now we have a start of 0, we have a middle of 5, we have an end of 10. Okay, now invoke all, it's exactly the same as back here. What do I call the method again? It's invoke task. Okay, it's the exact same, except it's going to keep doing the same thing recursively. Okay, it's going to keep doing the same thing recursively. So what does it do? Now, it creates a new manager, same weights. Okay, and it's going to go start, which we have said to be 0. Middle, which we have said to be 5. Okay, and then it's going to go to here. Int middle is equal to, so that is 5 of a difference. It's not less than or equal to 3. So it's going to go to here. So it's going to print off start is equal to end minus start. So 0 to 5 is 5. So half of that is going to be 2. Yes? Everyone understand that? Yeah? So, no, it doesn't. Okay. Do you know what? Fuck it. We leave it till tomorrow morning. We leave it tomorrow morning. We're a bit fresher. Right? I actually understand it now. I wasn't too sure I understood that when I first started doing it. I understand it now, which is one thing. There's still one small thing that we're getting 3 instead of 2. So there's some small bit of a flaw in the old logic. Okay?
That's what I was thinking you get.
Well, what we're going to do so tomorrow is we're going to put in, we're going to print off to say what's actually there. But here's the thing, right? So start is 0, middle is 5. Start is 0, middle is 2, end is 5. Start is 5, middle is 7, end is 10. Oh, that's right.
5 is given as index 6 as well.
Yeah, but hold on. 10 minus 7 is 3. 2 minus 5 is 3. See? Yeah. I think I have it. Tomorrow morning. Forget about it for now. Okay? Go home and think happy thoughts. All right? So,